Let's go ahead and get started with today's lesson, solving rational equations. Now, there's a couple ways you could actually go about solving these. One way is to find the least common multiple or a common denominator, in other words, and multiply the entire equation by that multiple to cancel the denominators out. Another way to do it to keep it consistent with adding and subtracting is to find common denominators and use a property of equality. Either way will work. So I think what I'm going to do is look through here and think, all right, I'm going to go with common denominators. So I'm going to reposition this, and I'm going to rewrite this equation with common denominators. So I'm looking through here, and I'm thinking about all of these denominators. And I'm thinking, what is the least common multiple of those? And I'm thinking it's 12v. So each one of these will be 12v. Now what I'm going to do is I'm going to take my numerators and I'm going to rewrite them in here and see if I need to change them at all. Okay? So let's go ahead and start by analyzing the denominators. So here's the first one that's new. I'm going to compare it to the older one. What do you notice is the difference between them? A factor of 4, right? So I'm going to multiply by a factor of 4 to the numerator. That makes it into the same fraction, actually. Let's move on to the next one. What do you notice that's different? About a factor of v. Let's compare these, and that's by a factor of 3, isn't it? So now that I've established that, what I can do is simplify this expression a little bit more. So I've got denominators of 12v, so it'd be 28 up here. And I'm going to go ahead and add these together. So that'll be v plus 27. And now at this point, what I can do is another property of equality, like we talked about before with exponentials and logarithms. I have the same denominator, so basically I can cancel those out. And I'm left with an equation. That is 28 equals v plus 27. So subtract 27 from both sides, and I see that 1 is v. And I just solved that equation, that rational equation. So that's just one way to do this. But I prefer to teach it this way because it provides more consistency with the way we added and subtracted and learned that process. Let's go ahead and try it with this. Now, what I would do here is make that as 5 over 1. So I think we should rewrite this equation and think about what's a common multiple. And I'm thinking it's w minus 7 times 1, or just w minus 7. I'm going to go ahead and put in my old numerators. And I'm going to do a comparison of denominators. So there's the original. Here's the new. How are they different? By a factor of w minus 7. Let's move on to the other ones. Look at that. Compared to that, you'll see no difference whatsoever. So I don't change the numerator. Same thing happens there. So I think I'm about ready. But what I can do up here is I can actually do a distributive property and write this as 5w minus 35. So now I could go ahead and add together my fractions. So I'll have a common denominator of w minus 7. Of course, over here it's a 2. Here it'll be 5w and minus 28. So according to the division property of equality, I'm left with an equation that if I add 28 to the other side is 30 and divide by 5, get an answer of 6. All right, so you look at that problem and you can see how that works out. Let's go on to the next one. Let's go ahead and keep working with this. So once again, move that up there a little bit. Let's pretend that's over a 1 so I can rewrite my equation. Look at those negatives in there, so we got to be careful of those. I'm thinking that I could actually do a little bit of factoring here. So take a page out of our playbook from what we've seen in the past. Now let's look at all of those denominators. 2 times x minus 2, and another x minus 2. I'm thinking that the common denominator, the least common multiple, will be 2 times x minus 2. Every one of those denominators would be a factor of that, aren't they? Now what I'm going to do is rewrite my numerators and see if we need to alter those at all. So let's make a comparison. Old denominator to new denominator. What are you seeing the difference of? Absolutely nothing. I'm going to keep my numerator the same. Okay, there's the 1 and that. Okay, so 2x minus 2 is what's different. Let's go to the last denominator. I see a factor of 2 is different. And now I can do a little work on this. Actually, what I think what I'll do here is I know that's 4, isn't it? So if I do a distributive property, it'd be 4x minus 8. And of course, this is the number 2. I think I'm ready to rewrite this expression. So one big fraction here for common denominators. Okay, so let's see what we have here. We've got a 4x. And then look at this. See how that's a negative 5 and negative 8? That makes a negative 13. And on the other side, it's a negative 2. So at this point, let's use our property of equality. Let's solve our equation. So if I add 13 to both sides, divide by 4, I guess 11/4 is that answer. And see the whole progress through here. Let's go on to the next question. All right, so I think before we go too much farther, we might want to look at this middle denominator and notice it's factorable. And that might give us a good idea of what these fractions should look like. All right, so what do you think the common denominator is, or the least common multiple? I'm thinking v plus 2 times v minus 2. Because every one of those denominators would divide into this, wouldn't it? And it's the smallest expression that gets the job done. We put in my numbers, and let's see if we need to change any of these numerators if the denominator is changed. So there's an old denominator. Here's a new. How is that changed? By a factor of v plus 2. The second set has not changed at all, so I'm not going to change the numerator. And this is different by a factor of v minus 2. All right, we can do a little bit more work with these numerators. So this will be 3v plus 6 here, and this is just v minus 2 there. That's a 2. It's a funny looking 2. All right, let's go ahead and rewrite this as 1 equation, v plus 2, v minus 2 with the denominators. So the numerators here would be 3v plus 12, and then v minus 2. Now we can use the property of equality. How about I subtract a v, subtract 12, divide by 2, got my answer. Let's try another. Okay, we got about 3 more to go. Lots of practice. Okay, I don't see any common factors here, nothing at all. No greatest common factor. So we're going to, actually, in this case, I'm going to change my method. There's nothing added or subtract on each side. How about we just do a cross multiplication for this? Remember doing that with proportions? We can certainly do that here. Okay, I'm going to collect everything to one side. I'm going to move these over here. It's probably a faster way to do this problem. Let's see if we can factor this. I believe we can. Let's see, we need two numbers multiply to give you negative 24 and add together to give you 10. I'm thinking negative 12 times positive 2 gets that done, right? So my solutions would be 12 and negative 2. And it's not a bad idea to check those, see if they actually work. And they're good. They're good. So you actually have two numbers that would satisfy that equation. Ended up being quadratic. So a proportion was a great idea to use there. Can't use a proportion here. Cannot. So what we're going to need to do is go through our process. I don't think there's any factoring that can be done either. Let's look at our denominators. And I'm thinking we're just going to have to multiply these, okay? So it's going to be w plus 5, w minus 7. Pencil in our numerators. Here they are. All right, let's do some comparisons. Old denominator, new denominator. How's it different? Factor of w minus 7. Old denominator, new denominator. How's it different? Factor of w plus 5. Old denominator is 1, new denominator is totally different. Okay, now, got a little bit of work to do here. I'm thinking we could do some FOIL methods ahead of time. So I'm going to do these mentally here. This will be w squared. The middle terms will cancel out, minus 49. That's the new numerator. Here, w squared, I'll have a minus 4w and a plus 5w's. That's plus 1w minus 20. Here, don't even worry about that 1. W squared plus 5 minus 7 would be minus 2w minus 35. Okay, we are ready to write an equation with a denominator of w plus 5, w minus 7. Let's check out what we have. On this side, w squared minus 49. On the right-hand side, 2w squared minus w minus 55. Now, let's use the property of equality. And let's go ahead and combine like terms. I'm going to move everything to the right-hand side. So my W squared is positive. So I'm going to add 49, which will be a negative 6. Let's see if we can factor this. I believe we can. 3 and negative 2. Let's look at the original problems here. Okay, just double checking to make sure that those actually work, and they do. Go on to the next one. This may be our last. This is the last problem. Could we factor this expression, this other denominator? I think so. I'm thinking 7 and 3 are going to work. And actually look at these. They're the same as those. So that's going to make my life pretty easy. Because I'm thinking the common denominator is x plus 3, x plus 7. Let's go ahead and check out, well, let's put our numerators in there. X, 5. We have an x minus 13 over here. All right, we're going to compare denominators. Here's the original. Here's the new. They are different by a factor of x plus 7. This denominator and this are different by a factor of x plus 3. And this denominator and this are no different. So I'm going to leave the numerator as it is. Okay, I think I'm going to want to do a little bit of work up top here. So distribute, and leave that alone. No parentheses needed. All right, I think we're ready to write this as actually a proportion. Okay, x plus 3, x plus 7 is the denominator. Numerator will be x squared, 12x, and 15, and x minus 13. All right, let's recenter that. Time to use our property of equality. So I'm going to keep everything on the left-hand side. I'm going to subtract an x. I'm going to add a 13. Let's see, can we factor that? I believe so. If not, we could turn to the quadratic formula. But I'm thinking that 7 times 4 is 7 plus 4 is 11. Negative 7 and negative 4. Let's just double check to make sure those are solutions. But I believe that they are. Ooh, we got a problem. That negative 7 does not work right here. So we're going to have to cancel that out. That does not work. We only have one answer, and that's negative 4. End of demo.